In this video, we talk about testing Wi-Fi access point roaming performance. When a mobile station starts to get out of the range of the current AP it's connected to, the station disconnects with the current access point and connects to the nearest AP with a better signal on the same network. And this process is called roaming. Wi-Fi roaming has predominantly been a station function, although in modern implementations and with protocol extensions like 802.11k V and R, the access point is starting to play a bigger role in the roaming process. The roaming process comprises of three main steps: roam initiation, roam decision, and roam execution. As a part of roam initiation, the station, although connected to the home AP on a specific channel, at regular intervals scans on other channels to create a list of potential neighbor APs to roam to when and if needed. With newer protocol extensions like 11k, the home AP can create the neighbor AP list for the station so that the station does not have to spend valuable time and energy scanning periodically on other channels. The roam initiation process can also involve caching security keys ahead of time in order to speed up the security handshakes in the event of a roam. The roam decision is the second step where the station makes the decision on when to roam. This step has also traditionally been a station function, and the station can decide to roam based on various thresholds like RSSI, signal to noise ratio, percentage of retries, and so on. But in new protocol extensions like 11v, the AP can assist and in some cases even force the roam decision on the station. Once the roam decision has been made, the third step is executing the roam, which involves disconnecting with the current AP, initiating a connection with the new AP, completing the required security handshakes and generating the required session keys, and then the network needs to route the traffic to the station through the new AP. All three steps need to work as efficiently as possible for the user to have the least disruption of service when it comes to roaming. Candela LANforge test systems can help test all these aspects of roaming in a very repeatable and automatable and scalable fashion. When it comes to roaming test methods, there are three main methods commonly used. The first method is the walk test. This method is as close as you can get to the real world and can test all three steps of the roaming process. But this method has a big list of drawbacks. This method is not scalable, not repeatable, not automatable, and basically ends up converting a highly qualified and highly paid test engineer into a person doing a lot of repetitive, unproductive, and unreliable mechanical work. The second method is using attenuators. In this method, we can use a piece of test equipment that can emulate one or more stations, or we can even use real stations and place the APs and the stations in isolation chambers by using programmable attenuators, control the signal between the stations and the APs, and roam the station using these methods. This method can test all three steps of the roaming process, and it can also provide repeatability and automation, but is still quite time consuming and can take several minutes to perform a single roam test. The third method is the forced roam method, when we can use a piece of test equipment that can emulate one or more Wi-Fi stations and send a command to the station to initiate a roam on demand. This method is mainly focused on testing the roam execution step, where the AP and the network elements behind the AP play the biggest role. This method is highly repeatable and also very scalable. Candela roaming test solution allows users to fully automate both the attenuator method and the forced roam method using a combination of Candela LANforge station emulation, traffic generation, roaming measurements, programmable attenuators, RF enclosures, fully automated UIs and automated scripts, executive style test reports, and expert analysis. In this video, we will focus more on the forced roam method. The forced roam method is primarily designed to test the roam execution step, which is where the AP has the most work to do. And given that we are focusing on testing APs, it makes a lot of sense to use this method for majority of the AP roam testing. Based on the security method being used, the roaming execution can comprise of many different types of messages exchanges before the roam is completed and traffic is routed through the new AP. Some of the protocol handshakes are listed here for various methods commonly used. The demo we're showing today focuses on testing how quickly and effectively the APs can execute the roams for various methods when having to deal with lots of roam events for long periods of time. This test is designed to stress the APs in many different ways in a fully automated fashion and find issues very quickly. So let's start with a simple roaming demo with the dual band Netgear R7800 access point in the device under test chamber and the LANforge test system in the tester chamber. This testbed, as you can see, also has programmable attenuators, but we're not going to use them for the forced roam method, as we can send commands to the Candela LANforge stations to roam on demand. We can also do this testing over the air without chambers if we can find a clean RF environment. Okay, now let's look at a simple roam test demonstration on the Netgear R7800 access point. So in this scenario, what we have done here is we're using the AP testbed that we had, where we have the LANforge inside a tester chamber and the Netgear AP in the device under test chamber. We can certainly put the LANforge system in the same chamber as the device under test, or we can do this test over there without the chambers if you find a clear channel, because you're using a forced roam method and we're not using any programmable attenuators for this particular test. I would recommend that you watch the video on how to set up a simple AP testbed and how to create a test scenario in the LANforge system before you watch this video to show how we get to this particular point. So in this scenario, what I'm doing here is I'm taking the same Netgear AP and I'm creating two devices under test here. One for the 5 GHz radio of the Netgear AP and another for the 2.4 GHz radio of the Netgear AP. And I'm going to treat them as two separate access points, although they're on the same physical AP. And I'm going to create one station on the LANforge system here and roam it between the two radios on the Netgear access point. Now we can certainly have multiple APs in this test setup, and we can roam between multiple APs or multiple APs in the same chamber or different chambers and so on. So if you look at this particular configuration, this is the 5G configuration for the device under test, and I put in the BSS ID for the 5G 5 GHz radio. And then in this device under test configuration, I put in the BSS ID for the 2.4 GHz radio. So to create a test scenario, I'm going to click on the manage scenario button here, and I'm going to create one station, 11 AC station, and I'm going to set the frequency to auto so that this station can go and connect to either one of these radios on the Netgear AP and can roam between these two radios as a part of the test. I'm going to initially ask the station to connect to the 2.4 GHz radio, and we're also setting up some simple UDP traffic to run between the wired network and the station as we run this test, so that we can use that to measure the roaming delay. On the upstream side, the LANforge Ethernet port is connected to the LAN interface of the Netgear access point, and that the upstream port will act as a server. So the traffic will be going between the station through the wireless interface of the Netgear AP, out of the LAN interface of the Netgear AP to the server that's created on the Ethernet interface of the LANforge system. So once I create the scenario, I'm going to apply, and then I'm going to build the test scenario. So to run the roaming test, I'm going to select the roam test option here under the test section, and then click on run test button here, and that opens up this dialog and that opens up this section where we can configure the various roam parameters. So the first thing I would want to do here is to create a roaming test script to roam the station between the two radios on the Netgear AP. So to create a script, I'll go to the script generator, and I will click on this query neighbors option. And so when we click on the query neighbors option, the station is going to send a neighbor report request to the AP, and it will read the neighbor report response from the AP. So in this case, this access point supports 11K, so it supports neighbor report requests and responses. And the response tells me that there are two access points or two BSS IDs here that I could potentially roam between. Now, if the AP does not support neighbor report requests or responses, we can certainly manually enter the list of BSS IDs that are available to roam between for that particular SSID. So now both these radios, although they are on different frequency bands, they are using the same SSID, so we can roam the client between these two stations. So once I select the list of BSS IDs that I want, I can also specify the amount of time I want to wait between roams. So I'm going to set it to like 5 seconds. So I'm going to run the first roam and then wait 5 seconds and then initiate the second roam. And also some information about which channels to scan on. That this gets automatically populated from the neighbor list, or we can manually enter that. So what we're really saying here is the AP is on channel 1 and channel 157. So we need to scan on those two channels. 5785 represents channel 157 and 2412 represents channel 1. If you're doing fast roaming, we can also select the FTDS and FT over there options as well. In this case, this AP is doing WPA to PSK, so we're not using fast roaming. So then we go and generate the roaming script. So basically what the script is doing is it's going to scan on both the channels, it's going to wait for a little time, and then it'll roam the station to this BSS ID, and then it'll sleep for 5 seconds, wait for 5 seconds, and then scan again, and then roam the station to this other BSS ID. And then this script will run in a loop. So which means every 5 seconds, the station will roam from the 2.4 GHz radio to the 5 GHz radio and back from the 5 GHz radio to the 2.4 GHz radio. And for each roam event, forced roam event, we are going to measure the roaming delay for each roam event and present that in the report. So I'm going to hit the start button, and now that launches this real-time report that we can look into measuring the roaming delays. And this provides a bunch of statistics and measurements in real time. So we can already see that the roaming has started, and then the AP is the station is starting to roam. So if we can put this on the side, we can see the green line here indicates which AP that the station is connected. Right now it's connected to the 2.4 GHz radio, but then it moves to the 5 GHz radio, and then moves back to the 2.4 GHz radio. So for each event, you can see the measured roaming delay, and the roam times are all measured and provided as a part of the report. So the first chart here shows the percentage of the roams that fell within a certain roam delay range. So for example, what this chart tells us is about 80% of the roams had a roaming delay between 20 and 50 milliseconds, which is the target range that we've specified. So, and then there were about 15% of the roams that had a roaming delay between 50 and 75 milliseconds, which is falling outside the target range. So this charts get updated real time, and we're also measuring individual station roam times for each roam. So we can see that the roaming delays range from about 35 milliseconds to about 42 milliseconds, and this delay is just the time taken for the roam to execute from the moment when the station is trying to connect to the new AP to when the connection has successfully completed. These results will also show more detailed information like how long it took for the security handshakes, and also it shows you how many roams happened, how many passed and how many failed. We can see the roams on a per AP basis. So these are the two APs we have. All 7 roams on the first AP succeeded. There was 1 roam that failed on the second AP. And there's more detailed information about other things like packet loss and so on. Now this is a forced roam method. We can certainly use the same test setup to do a roam based on attenuation. So the way we would do that is we would then put the two APs in two separate chambers, and then we would turn on the programmable attenuator between the tester and the device under test. And then by increasing the programmable attenuation between the LANforge system and the first AP and decreasing the attenuation from the LANforge system to the second AP, we can actually roam the station between the two APs using the attenuator method. There's another video on mesh testing. A link is posted here. Please watch that particular video to see an example of how the attenuator based roaming method works. Now, I ran this test overnight on this access point, and here is an example report of a test that ran overnight. So in this case, this test ran over 10,000 roams and about 5,000 roams on each AP, and you can see this AP did really well for a 12 or to 14-hour test. You can see the time on this x-axis, on the axis here. It started at 4 p.m. Yesterday evening, and then it went on till like 6 a.m. this morning, and it ran a long test, and it shows the roaming times of all the roams over time, roaming times for the APs over time, four-way handshakes time, and the total number of roam successes and failures, and as we can see, this AP is pretty consistent and can run lots and lots of roams successfully over a long period of time. Now let's look at a more advanced roaming test case. In this case, I'm using 4 Cisco access points connected to a Cisco wireless LAN controller, and the objective of this test is to do a little bit of a more large-scale wireless LAN controller testing and access point testing with different security methods. So each one of these APs has 4 SSIDs. So one of the objectives is to test and compare the roaming delay across different security methods as well. Now this test, I'm doing this over the air, but we can certainly put this inside all these APs inside RF enclosures. This is still a forced roam test, so we don't need any programmable attenuators for this test. As long as we can find a channel that is not busy and can provide repeatable results, this test can be done over there, but we'd highly recommend using RF enclosures for it. So if you look at the setup itself, as I mentioned, I have 4 APs. All 4 of them are on the same channel to simplify the testing, and each AP has 4 SSIDs. There's an open SSID, there is a SSID2 that does WPA2 pre-shared key. SSID3 uses EPTTLS .1x authentication, and it uses proactive key caching method. And then SSID4, we have 11R or fast transition enabled with the .1x authentication. So we have 4 SSIDs, the same 4 SSIDs on all 4 access points, and we have a bunch of LANforge stations that are connected to each one of these SSIDs and can roam between these APs. So for example, let's assume we have 16 stations here. I'll have 4 stations on SSID 1 that are roaming between SSID 1 on all 4 APs, and then I'll have 4 stations on SSID 2 that are roaming between the 4 physical access points SSID 2, and I have a single roaming test where we're executing lots of stations roaming between all 4 SSIDs, and we're going to measure the roaming delay for each individual roam and compare the roaming performance for the different security methods. The system also has traffic generation, and we are running traffic from the Ethernet endpoint through the wireless LAN controller to each one of these APs using the native traffic generation on the LANforge system. And we also have a radius server on the LANforge system itself locally, and this radius server is going to handle all the .1x authentications and certificate exchanges between the stations and the network. So let's jump to the UI. The UI looks a little bit more complicated here, and even though I have 4 physical access points, I've created 16 devices in a test here. Basically, I've created 4 devices in a test for each access point. So AP1 has AP1 open, AP1 pre-shared key, AP1 enterprise, and AP1 fast roaming. Similarly for AP2, AP3, and AP4. Now I'm creating lots of stations on the LANforge system. There's already a test running here, and these stations can roam between these APs. So to create a scenario, what I'm doing here is I'm creating 4 stations that are using an open station profile. So basically this station is going to be using the open authentication, and it's going to connect to the open SSID on the access points. And then I have another station profile that's used pre-shared key. So if you edit this profile, it's going to connect to the SSID Cisco PSK, and it's going to use WPA2, and this is the password. And I have 4 stations that use PSK that would connect to the pre-shared key SSID on the APs. And then I have an enterprise station profile, and we have here WPA2 and .1x EPTTLS enabled, and these stations will connect to the Cisco enterprise SSID. And similarly for 11R, I have a different profile. These stations will connect to the Cisco 11R SSID, and we have 802.11r enabled here. So in total, I'm creating 16 stations, 4 stations on each SSID, and these stations will roam between all 4 physical access points. Now I can go as high as 64 stations, and I can have literally hundreds and hundreds of stations roaming between all 4 APs in the test. If I really want a controller with lots and lots of stations, this particular LANforge system that has 4 radios, I can do 4 times 64 stations, total of 256 stations roaming between all 4 APs connected to the controller. So to keep it simple, I'm only going to use 16 stations here. So when I run the roam test, I can click on the roam test button here, and then click on the roam script, and then provide a detailed test script that actually roam all these stations. Right now I'm only roaming 4 stations, but if I'm using 16 or 64 stations, this roam script will be longer, and it's basically roaming each station between the 4 physical access points on whatever SSID that station is configured on. And I'm roaming all these stations across all the SSIDs. So when I hit the start button, it launches the report, real-time report, and we can actually see all these roaming delay measurements that are being made in real time. Now I ran this test overnight for about 20,000 roams, and I printed a PDF report. This is an example of a PDF report for an overnight test with lots and lots of roams. And this AP and this controller did really well. Almost 100% of the roams actually had excellent roaming delays. So you can see that a lot of the roams were well below the 50 millisecond roaming mark. And when we're measuring the roaming delays, we are measuring again the delay from when the station tries to connect to the new AP to the time which the connection process is successfully completed. Now you can see that there are some roams here and there over the overnight test that had higher roaming delays, as high as 500 milliseconds. But then for the most part, these APs work really well over a long duration test. You can see that we ran over 20,000 roams, and about more than 99% of the roams were successful. And you can see these roams across all these APs, most of them were successful. So now comparing the performance of this particular access points and the controller, and comparing the roaming delay with different security methods. So as I mentioned before, this AP and this controller was performing really well, and this was stressed in many different dimensions, with increasing number of stations, with lots of APs over a long period of time, and across all combinations, this AP seems to work really well. And you can see from these results, as I mentioned before, almost 100% of the roams were well within the target range of 15 milliseconds or less. Here in this chart, we compare the performance of the measurement of the roaming delays across different security methods. So of the 20,000 roams we ran, they were equally distributed among the 4 SSIDs with different security methods. So basically 5,000 roams for each security method in this test. And this is the average roaming delay across 5,000 roams for each security method. You can see that the average roaming delay when we used 11R fast roaming was about 5.4 milliseconds, which is really good. With .1x without fast roaming, about 20 milliseconds, and with PSK, pre-shared keys, about 20 milliseconds, and open was a little bit higher than the fast roaming roaming average. So the reason why these roaming delays are so low is because we are testing this in ideal conditions. The radius server is on the LANforge system, and the controller and the APs were working really well. Any one of these settings, like for example, if the radius server is somewhere on the network and there are additional delays to complete the security handshakes and the certificate exchanges and all of that, that would substantially increase the roaming delay as well. But overall, we can see that this AP and the controller performs really well when it comes to roaming. This is a chart that shows the results of all the 20,000 roams across time. So as I said, there was about 5,000 roams per security type. We can see that with the enterprise proactive key caching method, there were some cases where the roaming delays were very high, as you can see from these yellow bars. And also with pre-shared key, there were some cases where the roaming delays was very high, which are these gray bars. But with open and with 11R, which is the blue and the orange lines, most of the roaming delays were well under 50 milliseconds, and the performance was really good. Now let's look at a set of APs that are not performing really well with a similar test. I don't want to name those access points here, but we ran a similar test on a different vendor access points, and we ran a 10,000 roam test, and we can see across 6 access points, and we can see that this is not doing really well. I mean, there were more failures than successes for the roaming. So for each AP, more than 50% of the roams failed. And if you look at the roam percentage distribution, you can see that only about 2% of the roams or 5% of the roams were within the target range of less than 50 milliseconds. There is about 12% of the roams that had between 75 and 100 millisecond roaming delay, and there were quite a bit of roams, like for example here 5% of the roams had more than 300 millisecond roaming delay, and you can see that there's lots and lots of roams that had high roaming delays and lots of failures. If you look at this chart here, this is part of the report that comes from the test. Again, when we ran 10,000 roams, the roaming delays were all over the place, and it ranged from 50 milliseconds to 500 milliseconds, and you can see lots and lots of roams that had very high roaming delays here. That's also because it takes much longer with these APs to complete the 4-way handshakes and all the other security handshakes required, and because of this, there is higher packet loss on the traffic, and then overall high packet loss percentage.